Hey guys, it's Dr. Brown with Kubo Math coming to you from Tarlac City, Philippines, and tonight we have some pre-calculus and we're going to keep diving into the distance formula and also actually using that with circles. You know, if you have a cone and you cut it horizontally, you end up with a circle. So we're going to look at these circles and see what we can find, okay? Well, you know, with a circle, let's assume these coordinates are directly at the center of this thing, and this is 0, 0. Well, we know that if we have a radius out here, we have a side that's y, we have a side that's x. So we would say, well, x squared plus y squared equals r squared. That ABC formula, the Pythagorean theorem. Okay, well, why does that work out? Really, there's an additional piece of that formula. Really, it's stating that r squared equals x minus h squared plus y minus k squared. That equals r squared, or r would be the square root of that, okay? Where h and k are the center coordinates. Now the reason you end up with this formula is because h is 0, this would be h, and this would be k. So this is 0, h is 0, k is 0, so now it's x minus 0 squared, which is x squared. Y minus k, which k is 0, so y minus 0 squared is just y squared, and that equals r squared. So you'll see that formula written up here in its true form, where the center coordinates are h and k. So let's see what we can do with that. Let's work a few problems, some really cool problems actually, especially the last one. This is pretty sharp. Okay, how would we write the equation of a circle if we had a center point? Well, hopefully you can see that up here. Center point that's 5, -1, and the radius is 3. Well, 3 squared is 9. 9 equals, I've got an h that's 5. So I've got x minus 5 squared plus y minus a minus 1 squared. So 9 equals x minus 5 squared plus y minus a negative plus a positive. So that would be the equation of the circle with the center at 5, -1 and a radius of 3. Nothing to that. Well, I guess when you see it for the first time, you'll be like me, like, what is that? I understand. Okay, let's look at another one. Now the center is 0, 4 with a radius of 5. I'll put it over here. So I have a center of 0, 4 and a radius equal 5. Well, my radius squared, 5 squared is 25. Now I have x minus h, which is 0, that's squared, plus y minus 4 squared. So 25 equals x minus 0 is just, now it's just x squared plus y minus 4 squared. So that would be the equation of that circle with the center at 0, 4 and a radius of 5. Soon we're going to use many tools though to solve some of these. It's awesome. Okay, now we have one that I have a center at 3, -2. 3, -2. 3, -2, and it's telling me that the circle is touching the x-axis. Now I'm going to view that as its tangent to the x-axis. So 3, negative 2. So let's draw a grid here. 1, 2, 3, 1, 2. So 3, negative 2. So it's saying that's my center. But it's telling me that that circle is just touching the x-axis. You'll have to assume that's in the center. It looks a little off, but you get the idea. So that is the point 3, negative 2. Well, if it's 2 units down, and that's the center, and it's touching that, it's tangent, that means the radius is 2. It's 2 units down, and it's tangent to that point. Oh, okay. We almost have everything. We do have everything we need. Radius is 2. 2 squared is 4. 4 equals x minus h, which is 3, plus y minus a negative 2, which is y plus 2 squared. Minus a negative plus a positive. And that would be the equation of that circle. Okay? We are rolling. Learning these things is just about doing it over and over and over and over and over and over. Okay, now we have the ends of a diameter. I'm going to put my diameter looking like that. Ends of a diameter at negative 3 or negative 2, 3 and 6, 1. Well, all right, let's see here. I have some circle, and I should have drawn the grid first, probably. Let me draw a grid. All right, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right. So it says negative 2, 3. So I'm somewhere about in there. And then 6. 1, 2, 3, 4, 5, 6. 6, 1. So I'm right there. So we have a line going. Well, I kind of missed it. All right. I'll enlarge my dot. Okay, so you get the idea. We're up here at negative 2, 3. So x is negative 2, y is 3. And we're over here at x equals 6, y equals 1. And it says that's the diameter of a circle. So I don't know, somewhere in here I have a circle that's coming around like that. It's the center's in here somewhere. I don't know where. That's a bad looking circle, but bear with me. Okay. I need a compass here where I can make a better circle. And it wants us to find the equation of the circle by using that diameter. Now, my plan, if I think ahead, what can I accomplish here? I'm given a diameter, but I need a radius to be able to write the equation. Well, that's the diameter divided by 2, right? Now, I could, if I had a compass, I don't know how many of you have had graphics, but there's manual ways to bisect a line. You can actually go out here, if I had a string and had it, put my finger here and had the string tied to this, I could strike an arc out here, and I could strike an arc right over here, and then I could go to this point, I could strike another arc, and then from this point to that point, draw a line, and it bisects that line manually. Okay? And actually you can do that in 2 points on this circle, and where those lines intersect, that'll be the center of that circle. Okay, so you wouldn't have to calculate anything and then just read off your graph where it is. And then you could just measure then the resulting radius, and you would have everything you needed. However, we're going to calculate it. Just know there are other ways to do this. Okay, so we have a diameter that we could calculate using the distance formula. So we know the distance equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Square root of that sum would give me that distance, which in my case is the diameter. Then I can divide that by 2. It'll give me then what the radius is. Okay, so let's do that. So I've got the diameter equals x sub 2. We'll just let this be x sub 2, y sub 2, x sub 1, y sub 1. So x sub 2, 6 minus a negative 2 squared plus y sub 2, which is 1, minus y sub 1, which is 3 squared. Okay, so 6 minus a negative is plus a positive. That gives me 8. 8 squared is 64. 1 minus 3 is a negative 2. Negative 2 squared is a positive 4. So that diameter is the square root of 68. And you may be thinking, I don't know what the square root of 68 is. It doesn't matter, okay, for now. All right, so my radius equals the diameter over 2. So the square root of 68 over 2 is that radius. Woo! Big wooey. What does that do for me? Now, if I had drawn my line through here, as I mentioned earlier, I would know that my center point is somewhere about in here. However, we have a midpoint formula. We learned it in our last video. Oh, okay. Let's look at that. Well, if the x sub m, the midpoint of x, I take x sub 2 plus, well, it's x sub 2 plus x sub 1 over 2. So that gives me 6 plus a negative 2 over 2. 6 plus a negative is minus a positive. That gives me 4 over 2, and that equals 2. So I know x equals 2 is that x sub m. Y sub m is y sub 2 plus y sub 1 over 2. So y sub 2 is 1 plus 3 over 2, 4 over 2 equals 2. So the coordinates then for the midpoint of that line is 2, 2. Hey, not bad. So that is 2, 2. That's the bisecting that line. Now to check myself in terms of the diameter here, or the radius, sorry, diameter was given, and actually when you try to calculate things, since that was given, I would rather use the given material, the given information to calculate my radius than I had to use the midpoint first and then calculate the distance here. I am going to use that to check myself just to make certain, but if I had made a mistake and calculated this incorrectly, it's just better to use given information to try to answer the question when possible. Okay, but in our case now, we've already done that. Let's check ourselves. So we can use the distance formula again to see if we get this number. Okay. All right, where are we gonna, I need to clear a spot here somewhere. I tell you, I'm going to erase everything except the answer down there. And we'll use this spot right here to calculate. All right, so now we're going to do the distance. Oh, I erased my point. 6, 1. And this was x sub 2 and y sub 2, right? Yep. Okay, so now my distance, which is my radius, we're going to have x, again, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, and the square root of that gives me that distance, which is in fact my radius. So square root of x sub 2, which is 6, minus 2 squared, plus y sub 2, which is 1, minus 2 squared. Okay, 6 minus 2 is 4. 4 squared is 16, plus 1 minus 2 is a negative 1. Negative 1 squared is 1. This equals the square root of 17. And that is my radius. So it's the distance, and we're going d sub r. We're just going to go ahead and call it our radius that we've calculated. Radius calculated. Square root of 17. Now you're probably thinking, that's not right. Can't be. Well, let's square this number. If I square this, what do I get? I get square root of 68 times square root of 68, which gives me 68 over 4. Okay, 68 divided by 4, 1, 4, subtract that, gives me 28, 7. Whoa, 17. So r squared is 17. What does that mean r is? R is the square root of 17, if that's r squared. You thought I missed it. I did earlier too. When I worked it, I thought, oh, that's not right. Then I had to regroup there. Okay, but we still haven't gotten the equation of the circle, which is what we've been asked to do. Okay, r is the square root of 17. R squared is 17. So let's clean out a spot here. Okay, we know several things now. We know our center. This is h. That's k. We know that. We know r squared is 17. So r is square root of 17. R squared is 17. And that equals x minus 2 squared plus y minus 2 squared. And that would be the equation of that circle where we were given a diameter. I thought that was a nice problem. So because we had to use our distance formula to find the diameter, divided that by 2, got the radius, and then we looked at the midpoint formula to find h and k of that diameter, which if it is a diameter, the center of that would be in the center of the circle, obviously. Don't look at my circle, it looks a little off. But so we use various tools to get that. And we'll slowly build and build and build on those tools. I have another problem I've worked that may take an entire video, but it's fantastic. I'd like to get a compass and some other tools before I work that one, so we'll see what I can come up with here. Okay, that's all for now. Why are we doing this? Because together let's build a better tomorrow, and do that through math. Okay? Buy a child a book. Let's do that also. All right, that's all for now, and we'll talk to you next time. Thanks.